Question on chain reaction. The thermal decomposition of acetaldehyde is given by the following equation: CH3CHO to produce CH4 plus CO. Experiment reveals that the reaction is a chain reaction and occurs through the following mechanisms. Step 1: CH3CHO to produce free radical CH3 plus CHO with the rate constant K1. Step 2: CH3CHO plus free radicals CH3 with rate constant K2 to produce CH4 plus free radical CH3CO. Step 3: free radical CH3CO with rate constant K3 to produce free radical CH3 plus CO. Step 4: free radical CH3 plus free radical CH3 with rate constant K4 to produce C2H6. Derive the kinetic equation for the formation of methane in terms of measurable quantities. Solution. First, write out the rate for each of the steps. For step 1, rate equal to K1 in bracket CH3CHO. That comes as a result of having a reactant CH3CHO. So you use the reactant to write the rate for each of the steps. So for step 1, the reactant is CH3CHO. So that's why we now have in bracket CH3CHO. Then K1, which is the rate constant for step 1. Then for step 2, we have two reactants, CH3CHO plus free radical CH3. So that's why we have in bracket CH3CHO, in bracket free radical CH3. Then the rate constant is K2, that is for step 2. Then for step 3, we have only one reactant, which is free radical CH3CO. So that's why we have K3 free radical CH3CO. Then for step 4, we have free radical CH3, free radical CH3. So that's why we have K4, which is for rate constant for step 4. Then in bracket free radical CH3, then raised to the power of 2, because we have 2 free radical CH3 in step 4. Then after writing the rate for each of the steps, we now put down the rate of formation of methane, which is equal to K2 in bracket CH3 CH0, then in bracket free radical CH3. This is as a result of looking through the mechanisms. In step 1, if you observe, there is no CH4 present in step 1. Then you go to step 2, you have CH4 present and as a product. So what's the rate for step 2? The rate for step 2 is K2 in bracket CH3CHO in bracket free radical CH3. That is for step 2. That's why we have the rate of formation of methane is this. If you go through step 3, there is no CH4. You come to step 4, there is no CH4. So the only step that we have CH4 is step 2. And that is why we have the rate of formation of methane, which is only step 2. Then we also have 2 free radicals in the reactions, which are free radical CH3 and free radical CH3CO. We now write the rate for each of the free radicals. So the rate for free radical CH3 is equal to K1 in bracket CH3 CHO minus K2 in bracket CH3 CHO in bracket free radical CH3 plus K3 in bracket free radical CH3CO minus 2K4 in bracket free radical CH3 raised to the power of 2. Then for free radical CH3CO, the rate is equal to K2 in bracket CH3CHO in bracket free radical CH3 minus K3 in bracket free radical CH3CO. How do we get this? First, you look at the mechanism of each of the steps that we have. We have 4 steps here. Step 1, step 2, step 3, step 4. For you to write the rate for free radical CH3, you go through step 1. Do we have free radical CH3? Yes, we have. And it's present as a product. And being a product, that means it's being formed in the cost of chemical reaction and it's positive. So that is why it's positive here. It's not negative. So the rate for step 1 is rate equal to K1 in bracket CH3 CHO. That is for step 1. So that's why we have K1 in bracket CH3 CHO. The reason being that free radical CH3 is present in the first step of the mechanism. Then you go to step 2. Is free radical CH3 present? Yes, it's there. Look at it. And it's present as a reactant. And being present as a reactant means it's negative. So minus, that is how we have minus here. Then the rate for step 2 is what? The rate for step 2 is K2 in bracket CH3 CHO in bracket free radical CH3. So that is why we have this. The reason being that free radical CH3 is present in step 2 and we have minus because it's present as a reactant. If it's present as a product, it's positive, just like in the case of step 1, present as product. Then we also go through step 3. Yes, it's present, free radical CH3, and it's present as a product, so it's going to be positive. So what's the rate for step 3? The rate for step 3 is K3 in bracket CH3CO. That's why we have this. Then minus, you go through step 4, is present and is present as a reactant. So being present as a reactant, that's why we have the minus sign. Then we have 2, then K4 in bracket free radicals CH3 raised to the power of 2. Then how do you have these 2? Let's take for instance, for us to write the differential form of 2A in this chemical reaction, that will be rate equal to minus 1 all over 2, which is the coefficient, dA all over dt. So if you look at what we have now, which is the step 4, if you go through step 4 now, look at step 4. In step 4, we have 2 of free radical CH3. That's why we have these 2 here. And that this can also be equal to 2 radical CH3. So for us to write the differential form of this, and this will be equal to minus as a reactant 1 over 2, the coefficient, then the free radical CH3 all over dt is equal to the rate for step 4 is what? The rate for step 4 is K in bracket free radical CH3 raised to the power of 2. So that's why we have this. So then from there we now solve it. Solving it, we now have multiply both sides by minus, then the minus will come over this side, then we cross multiply and cross multiply, and because this is what we are looking for, we are looking for the rate of free radical CH3. So we now have the rate of free radical CH3. So these two we cross multiply and we now have minus 2 K4, then in bracket CH3 raised to power of 2. So that is how we got this minus 2 K4, then in bracket free radical CH3 raised to the power of 2. Then for free radical CH3CO, the rate is equal to K2 in bracket CH3CHO in bracket free radical CH3 minus K3 in bracket free radical CH3CO. How do we get this? First, we look at the mechanisms. In step 1, do we have free radical CH3CO? No, we don't have it. In step 2, yes, it's present, and it's present as the reactant. That's why we have positive, or it's present as a product. That's why we have positive. Then we now write out the rate for step 2. The rate for step 2 is K2 in bracket CH3 CHO in bracket free radical CH3 minus, we move to step 3. Is it there? There, yes, it's there, and it's there as a reactant, which is free radical CH3CO. It's there as a reactant. So that is why we have minus. Then the rate for step 3 is K3, then in bracket CH3CO. That's how we got this. Then we label it equation 1 and equation 2. Applying steady state approximation in equation 1 and equation 2, we have the whole of this, which is equation 1, is now equal to 0. Then the whole of equation 2 is now equal to 0. From equation 4, which is what we have here, this is equation 4 now. So from equation 4, K2 in bracket CH3 CHO in bracket free radical CH3 will now be equal to, this will now cross the equality sign and become positive. So that's why we have K3 in bracket free radical CH3 CO, which can be substituted into equation 3 as follows. This equation 3, which is equal to 0. So when we now substitute K2 in bracket CH3 CHO in bracket free radical CH3, so we now have K1 in bracket CH3 CHO, which is this, minus, in place of K2 in bracket CH3 CHO in bracket free radical CH3, we now substitute and replace it with K3 in bracket free radical CH3CO, because from equation 4 we have this. So we now substitute it and we have this, plus K3 in bracket free radical CH3CO minus 2K4, then in bracket free radical CH3 raised to the power of 2 equal to 0. Then on doing that, we now observe that this and this are the same and with different signs, so they will now cancel each other, and we are left with K1 in bracket CH3 CHO minus 2K4 in bracket free radical CH3 raised to the power of 2 equal to 0. Then we solve the problem and make free radical CH3 the subject formula. On doing that, we now have free radical CH3 raised to the power of 2 equal to K1, then in bracket CH3 CHO, which is this, all over 2K4. Then we find the square root of both sides. So finding the square root of both sides, we now have free radical CH3 equal to the constants raised to R, which is the square root, then CH3 CHO, then the square root. Then on doing that, we now have the free radical CH3, which is equal to K1 over 2K4 raised to the power of half, then in bracket CH3 CHO raised to the power of half. From there, we now recall that the rate of formation of methane is equal to K2 in bracket CH3 CHO in bracket free radical CH3. So we have to eliminate this, and we've solved for this free radical, which is what we have, K1 over 2K4 raised to the power of half, then in bracket CH3 CHO raised to the power of half. So we now substitute this in place of free radical CH3. On doing that, we now have this. Then when that is done, we now observe that CH3 CHO, and we also have CH3 CHO raised to the power of half, and we now factorize it, and we now have CH3 CHO raised to the power of 1 plus half. On doing that, we now come to this point where we have CH3 CHO raised to the power of 3 over 2. This is the rate of formation of methane. This is the rate of formation of methane. Thank you for watching. Please remember to subscribe for more material. Thank you.